Assalamu alaikum dear students, we're back with another video lesson. In the previous video lesson, we were talking about generators. We said generators are machines that can convert mechanical energy into electrical energy. We also mentioned that there are two types of generators. There are AC generators and DC generators. We said AC generators produce and bubble and generate alternating current, while DC generator generate direct current, or you can say a current that is only in one direction, or the direction doesn't change, only the magnitude change, while for AC both magnitude and direction were changing here. And then we ended up right at this point here. We have the variation of the direction of the alternating current here. Now we can talk about alternating current as a definition. We can say alternating current, it is an electrical current that change direction at a regular time interval, but not only the direction, it can vary its magnitude as well. What exactly do you mean by this? Previously we've mentioned this one. Direction, magnitude. What do you mean by that? As you can tell here, or as you can see, for example, now we have, if this is the voltage that is generated here, or the EMF, you can see that we have the positive part and the negative part, and that is obviously changing the direction, because for half a cycle it is, or the direction of the current is, let's say positive, the other half it is negative. It's the same way as if we say, for example, for half of a cycle it is to the right, and then for the other half it is to the left, because this is what exactly means as it is alternating here, or when we say the direction is changing. And then as for the magnitude, you can see that it's obvious that at some point, or you can say that we start from zero, or the origin here, so you can see that the magnitude keeps increasing until it becomes max positive, that keeps decreasing until it becomes zero, then after that keeps, for example, changing until it becomes max negative, and then goes back to zero. That'll be one full cycle. So you can see that in AC, both the direction and the magnitude are changing, So this is what we say AC here. So if you note what we have in this figure 611 here, you will notice that it says that the EMF, or the alternating current, or the generated voltage here, it alternates, it varies, it changes, from a positive to negative. This happens, by the way, 50 or 60 times in 1 second, depending on the country. Some countries, let's say, it alternates, let's say, 50 times or 60 times in 1 second, That would be the frequency of this alternating current, by the way, as well, So this, you can say 50 or 60 times per 1 second, depending on the country. As a result, the output current, from the generator changes, it is magnitude and direction, you can say, This variety, this change of a current, it is called alternating current. Why? Because it is altering, it is changing from positive to negative, that is the direction, and also the magnitude too. So we call this one alternating current, or more commonly we just call that AC. AC stands for alternating current. Now there are a few points that are worth mentioning at this point, especially the last one is very important. Well, what is the first one? It says the rate at which the coil in a generator rotates, of course, that determines the maximum EMF. What does, or you can say that determines the maximum EMF generator. What exactly do you mean by this? Like previously, where we're saying that EMF generated, what is it equal to? Or maximum EMF generated, maximum, the kata NAB omega, or we were calling this one Nabu, like just does something to remember. So the faster that it rotates, for example, this would be the number of turns, this is the area of a coil, this is the magnetic field strength. As you can see here, we have omega, which tells you how fast the coil is rotating. And you can see that the relation between the two is directly proportional. In other words, the faster the coil rotates, that means the more the EMF, or maximum EMF, that is generated. And then the second point is we have something called resistors. By the way, there are some devices that can be connected only with AC, and some other devices with DC only. And what are these, for example? Let's say a heater, for example, it could be connected to AC, right? Because it doesn't matter how the current is, for example, flowing or going here. Positive, negative doesn't matter, because eventually it heats up. There are some other, let's say, devices that can work with AC as well. Another example would be, for example, a refrigerator. And then, but on the other side, there there are some devices that can work only with DC direct current, like what? Like your cell phone, for example. But we have some other devices we can say, for example, like a resistor. It doesn't matter which one is connected to, it can always resist the flow of current. And resistors, you can say mainly, or for most of them, they convert electrical energy into thermal energy for some of them, but their main job is to resist the flow of current. What are resistors? We can say resistors resist the motion of charges regardless whether they move in one direction or both direction. In other words, resistors resist the flow of electrical charges regardless whether this current that is flowing, it is direct or alternating. It can be connected with both types of current here. But then there is this point here, which is the most important point, and that is the average value of the alternating current, AC current at one cycle, or we can say during one cycle it is 0. What does exactly this mean here? Now, previously we were saying that alternating current, it alters between positive and negative, right? So if we take an average here, let's say this side is positive, right? And whatever this side is, of course, is going to be exactly the same on the other side here. So this side is going to be negative, Basha. This side is negative, but if you want to find the average, this side, of course, for one full cycle, this side is going to cancel the other side. So the average current during one cycle, it is going to be 0. As it could be during 2 cycles, during 10 cycle, it doesn't matter. That is always going to be 0, Basha. Unless if it is, there is half a cycle left, which we don't have anything like that. But as long as it is half a cycle, because we have half positive, half negative. So whatever the values are, for example, this side here could be maximum 10 positive, or positive 10. The other side is going to be maximum negative 10, right? So as you find the average, how do you find the average, by the way? Average current or voltage doesn't matter. You're going to combine the two, Basha, and then divide by the 2. But this 2, obviously, it is equal to 0 over 2, doesn't matter, just 0. Got the average, you don't have, or you don't need to know this one. Just remember, the average value of the alternating current in one cycle, it is equal to what? It is equal to 0. Why? Because half is positive, half is negative, and they always cancel out here. We have question 14 here. What does question 14 say in here? It says a student turns the handle of a small generator attached to a lamp in a socket, let's say, or lamp socket, containing a 15-watt bulb, Basha. But the question says the bulb barely glows. What does barely glows mean? يعني هروية glopaka ish dekat يعني runachike zozo kama يعني it is very dim, Basha. يعني it is dim يعني runachike zornia. What should the student do to make the bulb glow, Basha, more brightly? بابلنا وقتها بيد تواني سبكات نهتا glopaka برناتشي زياتر بدرو شيتو Basha. قال لي بابا, the generator, we have a small generator. Once we say we have a small generator, that means you have this, right? You can have maximum EMF, for example. We were just saying that is NAB omega, right? So because it is a generator, obviously it has a specific number of turns here. As the liberator generator, we already have it. Of course, you're not going to change the number of turns at this point here because it is already made and fixed. And the area of a coil that is also made and fixed, you can say the magnetic field is also, for example, made and fixed here. But the only thing, for example, that the student can do is he can, or they can actually rotate the handle of a generator faster, because earlier we said that these two are directly proportional. So the faster the handle is being rotated, or it is rotated, then we can say more EMF is generated. And the more EMF is generated, that means the more current, the more, let's say, potential difference would be on the light bulb, and eventually it is going to bright more, or it's going to glow brighter, Basha. By the way, the student could possibly, for example, if they could change any of these, that would be totally fine, by the way. The more variables you change here, the more EMF you get. But at this point, since the generator is already made, the only thing that now you can do is by rotating the handle faster, Basha. That would be the answer to that question. We also have question 15 says, what is meant by the term frequency in reference to the alternating current? I believe this is nothing new to you, and yeah, Basha. What is meant by frequency? In chapter 3 we've studied that frequency the number of waves per unit time. That would be the definition of frequency. But specifically in reference to the alternating current, لباسي بابلن alternating current. How can you define frequency? We can say frequency it is the number of times باشا استاجر frequency يعني بابلن ليرة بتوع wave شي درسكي for current exactly. What exactly happens here? قلت ما نبونو عليه ده كواتا ده تواني بلن frequency that is the number of times باشا جماري أو times عنيا where the current reaches قلت ما increases يعني becomes maximum positive أقل بي ده decreases to become maximum negative باشا أوج ليرة maximum بس negative ده back to zero يعني هو يك cycle تا ونيا كواتا how many full cycles like this in 1 second أو دبيتا frequency باشا تشكي frequency دكاتا جماري وإذا كان the number of turns divided by the time باشا يعني بابلين in 1 second باشا to be more specific كواتا frequency the number of waves or how many waves complete waves in 1 second that'll be the frequency بابا قال لي كواتا بس لي يك ويفي يعني بابلين جماري ويفاني كهايت مانسيلي ده كرنتك زيادة كاتن لصفري لو maximum positive دو decrease دبيت النتا دبيتو maximum negative دو back to zero. It's sun wavy أوها يعني sun cycle أوها in 1 second that is going to be frequency and of course is you do know the unit of frequency which is measured in hertz من يا أوه بابلين بساري خوش آسان بساري شدي كمان هي ليرة when the plane of a rotating loop of a wire is parallel to the magnetic field lines, the number of lines passing through the loop is 0. But then why is the current at this point that is maximum, Basha? When we were talking about the coil, but manskatek, we get maximum EMF in a generator. Magnetic field line can they are parallel to the plane of a coil. And when the magnetic field lines are parallel to the plane of the coil, we get maximum EMF. Labita Basha. When the magnetic field line are parallel, no magnetic field line is crossing and bubbling, moving, crossing into the coil. When you magnetic field dana coil kinabron and they don't cut through the coil, and then why is the current that is induced is maximum? It's true that the let's say what is it called? The plane of the coil is, and the magnetic field line is parallel to the plane of the coil. But Gutman, how is the plane of the coil moving? Like at this point here, Basha, you can see that at this point, the plane of the coil, it is moving, for example, rotating, and that'll be, we can say, the angle between let's say the direction where the coil is rotating, which is, we can say at this point it is upward magnetic field, it is parallel or horizontal. The angle between the two is 90 basha. Or magnetic field which direction the angle between the two 90 agar angle بيني ودوي 90 ببابا magnetic force كده say that one QVB sine theta. There is maximum force on the charges here. And these charges, of course, or maximum force on the charges, maximum charge separation, لو ده بيتا maximum EMF. وش ما خيم كاتا لو حالتي بابا ده بيتا لتوانين بلن BLV ونيا. The angle between the direction of the magnetic field line and V also is going to be 90. That, of course, produces maximum EMF ونيا كاتا voltage. So this one because the magnetic force on the charge is greatest at this point, resulting in the highest range of change of magnetic flux, that induces maximum EMF. Basha? قال لي ببابا بيد بين مو بابا كنت عن سكاتك magnetic يعني أو EMF قادر is the bit is maximum أو كاتي when the magnetic field line is parallel to the plane of the loop باشا بس باسي موشناكن باسي plane loop كده كان هذه سكاتك قلت مان EMF كزيرويا when the magnetic field line are perpendicular to the plane of the loop باشا أجرو plane loop كيبتن when the magnetic field line are perpendicular that will be 0 EMF. Once it is parallel, there is going to be maximum EMF. Maximum EMF, Baba, of course, is going to be maximum current as well because we have a closed loop or circuit there. Estaka Persari, Bistu or 24. Basha Persari 24 is also a good question. Sometimes students struggle with this one, Baba. Let's clarify this a little bit. It says a bar magnet is attached perpendicular, Basha, to a rotating shaft, as you can see here. So there's a bar magnet. Basha, there's this rotating shaft in here. So there is a coil, or you can say a bunch of wire here. A coil, you could just call that, Basha, in which the magnet is placed inside the center of a coil of wire, in which the arrangement, the arrangement shown below, in which of the arrangement shown below could this device be used as an electric generator, Baba? There are 4 different methods to induce EMF. Like we've studied that at the beginning of chapter 6. One of the first method by moving the magnet closer to the circuit or away from the circuit, or you could move the circuit, doesn't matter. And then the second method was by rotating the magnet or the circuit, doesn't matter. The third method by increasing or decreasing the intensity or changing the direction of a magnetic field. The fourth method was by changing the cross-sectional area. The fourth one was the least efficient or the least common one here. If you look at this case here, channel diagram أنا دكري بكاربه وكو جنريترك باشا اگر تماشا چيرك بابا قلت man conditioning away bablan in order for this to be used as a generator لو يهتاوكو جنريترك بكاربه دبي magnetic field كه بقوره باشا دبي magnetic flux كه بقوره so magnetic flux كه كدلين magnetic flux كه بقوره بابا بس ما جماري او لاينانيه the number of lines that are cutting through these wires, or you can say the coil. Basha agar jmari a magnetic field nani kwa they cut through the wire. Okay, magnetic flux ka change dabi agar magnetic flux change bi yani you have EMF induced and a current as well. And these two, of course, now can be induced. Then, of course, you can use them as a generator. But diagram as you can see here, this is the magnet. This magnet can rotate, by the way. You can see that this is the direction of a rotation. But دم تركيز لسريكش تبكي بابا قريمان أو واركيا تنها تماشا إيربكا أو magnetic. This is how the magnet is rotating. This is one side of it, or you can say the upper side of it. As the magnet تماشا إيركا, you can see that at this point the magnetic field line is cutting through bubbling the wire. As the magnet is getting bubbling rotating. So this is how it is rotating. Are the number of the magnetic field line that are cutting through this wire or coil, bubbling this segment of the coil, is it changing or not? Bubbling magnetic field this is the bar magnet. Bar magnet rotate the bibaba because that would be, this is how it can rotate. You can see that. As the magnet is rotating, this is how it is going to rotate. Jmare or bubbling jmare يعني نمبري magnetic field line كان ليرة زورة as it is moving away جماري أو magnetic field line كوكتي أو بشي واركي يعني كويلة كده كان it decreases up this point becomes 0. After that you can see that the other side is getting closer كواتا بولكش غورة on this side so at this point you can see that both the number and the direction is changing. This one can be used as a generator. What about this one? This is exactly the same thing, but instead of rotating the magnet this way, we'll rotate the magnet this way, like horizontally. Doesn't matter. Now it is the same case. At this point, maximum number of magnetic field line is, you can see that is cutting through the wire. As the coil is being rotated here, you can see that magnetic pole magnetic field that are cutting the wire also decreases. حتى دقرته بابل ليرة دتواني بالصفر ليرة دبيتو maximum بس لأكيد كيا كواتا we can say the direction will change at this point here. Also, the main point is the number of the magnetic field line is going to change so there's a change in flux. As long as there is a change in flux, there will be EMF and current induced as well. كاتا أوش تكريو كوجنريتر بكاربه بس أجت تماشات يعني من حظة شيء بكي بابا لما عندك تركيز زيادة كليرة أجت تماشات كليرة بابلين أو magnetic field line كان rotation كا يعني أو بابلين this is part of a يعني segment of a coil magnetic كود صورته وبناء صورته كاتا أجر أو واير كبيتم باشا ليرة magnetic the magnet is rotating like this باشا ليرة دتواني بلاي استا maximum magnetic field line is on the wire بس استا لجاتي بابلين أو ها بصورته وبناء like getting away or closer, it is just moving, for example, to this. Yani once this point here, it's like this. When if you look at the there are magnetic field lines on this wire here. But then after the coil is rotating, magnetic field line those that are on the wire doesn't change at this point. In other words here, no matter how far or how much the magnet is rotating, baba, jmare or magnetic field line the cut through the wire doesn't change. Later griman it is 3. After that, at this point it is always, at this point it is 3 as well. Once it is rotating, that is also 3 as well. Kawata jmare or magnetic field line that are cutting through the wire does not increase or decrease And if it does not increase or decrease, that means the flux doesn't change. When you change in flux is 0, agar flux nagora aukati, there is no EMF. Agar EMF is nebit, of course, there's no induced current. Kawata, this one cannot be used as a generator, but this too can be used as a generator. بابا لو دوار دكمو قلت ما ليرة لبري بولي ماغنتكي هان زيكو دور دكويتو لو عركان كواتا جماري او لايناني كواركي دبريتن كم زياد دكا يعني فلكسك غورا ليرة جعينا نشتا باشا جماري او لايناني كوا واركي دبريتن يعني passes through the wire, it increase and decrease when again there is a change in flux. But later, no matter what you do, Baba, it doesn't change here. Later عين نشتا ليرة عين نشتا ليرة عين نشتا. The number of magnetic field lines on the wire does not increase or decrease. That means there is no change in flux. Agar change the flux there is no EMF induced. Agar leave Basha later the toning blend diagram A U B can be used as a generator but not C. The faster the coil of a loop on bubbling of an AC generator rotates, the harder it is to turn. Basha, bubbling, turn the generator or rotate the handle of a generator. Use lenses law to explain this. Basha, bubbling the generator طبعا حتى خيري سورانوي كويلكي لنا ماغنتيك فيلد كي زاتر بيتن سورانوي كويلكي قرص ترد بيتن يعني زحمة ترد بيتن. Basha, why does this happen? Use lenses law to explain. Basha Khoma Gutman lens Guti when bubbling what is it called, for example? When a coil rotates inside a magnetic field, EMF generate the coil, right? So this EMF is passing through the coil of bubbling the wire of a coil. Kawata, is this current passing through the wire of the coil? That EMF, bubbling, that current produces its own magnetic field, right? Kawata, the magnetic field of the coil, you have to imagine this one. Let me draw something, hopefully that might help as well. Now these are the wires of a coil here, Basha. As this coil is rotating inside a magnetic field, Gutman, and there's also the, Gutman, we can say the permanent magnets too here, Babylon, later north, later south. As this coil is rotating, Gutman, EMF and current will be generated. Because EMF and current are generated here, there will also be another, let's say here's a current flowing through this Basha. This current that is induced here, it would have its own magnetic field, Baba. So now these two magnetic fields, of course, going to oppose one another. So here's the thing. The faster the rotation, the more EMF and current will be induced. The more the current, the more the magnetic field, the more the opposition. Babi kana kurdish Basha. Gutman, when كاتكوا كويلة كلنا magnetic field لكي ده صورتها EMF أكو كرنتك درجة دبي بابلين كرنت ليرة باشا حتى خيراي صورة نوكي زياتر بي أو كرنتي كوالنا كويلة كي generate دبي زياتر دبي باشا بيشتريش من باس كده chapter 5 قلت ما نقدر كرنتك بناويرة شي دابروا يعني كويلة شي دابرات نوكاتي it would produce its own magnetic field كواتا استاو magnetic field دي كوا induce بوا يعني بابلين كرنت induce كيا لقال أو magnetic field داني كوا external magnetic field and they oppose one another لويا عندك قرص دبي حتى كويلة كبصورتها حتى خير أي صورة نوكي زياتر بي أو magnetic field دي induce دبي زياتر دبي تن كواتا opposition كان زياتر دبي تن دتوانين بلين لبر أويا باشا كوا سورانوي كويلة كلناو magnetic field دكي زحمة دبيتن باشا يقدو بساري وزاري من هي ليرة بساري كمان ضلت say which of the following will increase the EMF produced by a generator هركاتك شتشي واديد بابي كوشنا كله خد بنسا قطمان EMF E generator دتوانين بلين دكات N A B omega sine دتوانين بلين omega T باشا أول ليرة you can call this one instantaneous يعني هر يقلو أنا it affects the EMF induced. Then I get blend maximum okay, we would have just wrote NAB omega. Basha lizati omega 20 blade 2 pi f and the frequency of the rotation that'll be the same thing at this point here. Basha yan bubbling angular frequency is the same thing. Kata yakam option delay rotating the generator coil faster. Kata the faster the rotation, the more the EMF. That is true, Basha. But let's check out the other options too. Option B says increasing the strength of the generator magnet. Basha, I get strength magnetic increase can kata magnetic field like ziyad bo. Kata khali kam gutman if we rotate the coil faster, EMF will increase because each one of these are directly proportional. When you're increasing the magnetic field strength, that also increases the EMF induced here. C, option C says increasing the number of turn also. And increasing the number of turn also increases the EMF induced. At this point, we can say all of the answers are correct at this point here. Basha, the second question says, which of the following equation is correct to calculate the magnitude of maximum EMF? Basha, maximum EMF for a generator. But man, هر كاتا قلتي maximum you don't write sin theta تسنك أو كاتي sin theta همي أو بشر دبيتا 1 كواتا قلت man equation كتسيلة دبيتا N A B omega ونيا or you could just call it nebu at this point here. Kata, which one of these would be correct? That is going to be option C because it is NAB omega. زور باش تيدي كاش معناها alternating current can be converted to direct current. طبعا اوش خالتشيان دتوان بلم او بششان زوزو جرينجا قاعد ليبي دتوان AC بكينا DC باشا. How can we do that? يانيش بيتانا كشراستا دتوان DC بكينا AC. How do we do that? Well, we said that if you remember earlier قلت مان جاوزي بيني AC generator و DC generator دتوان بلن لبش سرتش كان. And it's one thing. It was the third point. ونيا قلت مان ل AC تمانيا we have two slip rings, Basha, two slip rings I think I've mixed, like sometimes unconsciously I've been mixing the two, Basha. So you be aware of them, all right? So for AC, we have two slip rings Baba. But in DC, we have one commutator or commutator, which is one ring that is split. We have one split ring for DC. For AC, it is two slip rings. Estaka, agar AC كمان هبو two slip ring كي لعبة replace كلجال شيء لجال commutator شيء أو كاتي we've converted AC to DC. Basha. What if we want to do the reverse to go? It's been in Wizari, by the way, both of them. Can we convert a DC generator to AC? Of course, yes. As that commutator كي لعبة Basha replace كبتشي but two slip rings أو كاتي you can convert DC to AC generator. Basha, Gutman, these are the parts. This is the diagram for AC and this is DC. I got to AC convert kilo DC baba. Okay, I'll do slip ring bugo rabache by a commutator yan one split ring. I'll do slip slippery rings bugo raba commutator yanish one split ring okay the beta DC. أديك mana عكسي كنا DC كي bugo rain lo AC okay but mana commutator bugo rabache but two slip rings أوكاتي دبيتا AC generator. تيدي كاش معناها أو خالي إيرش اللي بينتي باب ضل AC generator can be converted to DC by replacing the slip rings with what? With a commutator which consists of a single split ring. أقعد أو خالي بي. تيدي كاش معناها بابا. This is the diagram, or you can say this is the DC current, which is, you can call this one a pulsating DC current, by the way, Basha, because it is like a pulse, it is only positive. Don't forget this one here. Negative part, it is converted and flipped into the positive. AC negative, it is converted and flipped to the it became positive by using a commutator, or you can call that a slip ring. Basha. It changes the direction of the current that is induced so that it is always in one direction. How can an AC generator be converted or can be converted to a DC generator? Gutman, replace the two slip rings with a commutator. That is how easy it is. Commutator, of course, it is consisting of one bubbling split ring. I got it. What if we want to convert or do the opposite? How can we convert a DC generator to, or convert that to AC generator? Do slip rangi لزيدانه أو كاتي دبيتا AC generator. How بسارة وزاركيا باشا ليش تشدي كمان هي بابا. This AC that is generator I get to masha I get lebid booby. Let me talk about this one a little bit here. With mind this current that is generated, or this EMF, doesn't matter at this point here. Now the one that is generated, this is how it looks like, right? Yeah. Good man. We can make this one a little bit more steady. Basha, because now DC from a battery, it is direct, it is straight, there's no bumpy, it is just a straight line one, yeah? So you can say that this is DC from a battery and this is DC from a generator. But do you know that if we use many loops and let's say commutators, then we can sort of convert this one to something like this. Let's use different color. So to something, for example, like this one here, less at this point, less up and down here. And how can we do that? So this is how we can do that. By using what? By using many loops, Babylon, and commutators here. For example, instead of using one coil here of one loop, and then let's say one commutator, we'll use many loops in here. So for example, here's another loop, Basha, and then there is another loop here. So of course you could, if I draw this, that is going to be a little bit messy here, but each one of these, of course, you can see that it is connected to Babylon, many commutators here. So which once it is Babylon maximum, as you can start at any other point, of course, here. Basha, once it is maximum, it's about to, for example, decrease. Now, there will be another coil, Basha, Yan Babylon, there will be another part of a coil where the magnetic field is parallel to that coil. Babylon magnetity او EMF يعني current generated but does not decrease until it becomes zero. It just switches and Babylon connects to another commutator, another coil, so it becomes another maximum here, and then after that this is how it goes or continues more and more until you see this one here. Got that? This AC, this is DC with Babylon one commutator, and this is with many coils and commutator. Each one of these, we can say that there are many coils. You can see that there are many commutators here. What exactly the benefit of this? But each one of these commutator, magnetic Babylon directionally magnetic في line okay. If it is parallel to the coil لو كاتي EMF كمان maximum ونيا لذاتي تعرب كن coil كروتيت كات نهتا هتا روتيت تبي بقرة ولا أكيد كنا. Again, for example, we could use many coils. Babylon direction okay, go a little. Another coil would be connected, Basha, and would come forward where the magnetic field would be parallel to that. Basha, Gutman harka coilak direction okay, yaqiz gora, Basha. Aukati coilet shidika will be aligned. Coilet shidika, Babylon, the plane of that coil will be parallel to the magnetic field line. Aukati will get another maximum EMF Wrya. That one in blend. This is how it looks like, Basha. So this is, we can say, smoother, more constant, and less bumpy at this point here. We can do that or achieve that by using many commutators and coils, Basha. And this is another actual example of what you will see, Basha. سيدي كشماني بابا موتورش مانيا باسي موتورش كان زور بسريعي موتور The twinning blind motors are exactly opposite to generators. Basha, of course, in terms of the main components, Basha. So what are they made of? Or you can say these motors are, these are machines that convert electrical energy to mechanical energy. This is very important. Where we're saying that generators are machines that convert mechanical energy to electric. These are machines that convert electrical energy to mechanical energy. Yani Griman, for example, something like a water pump. When you will, let's say, connect the circuit and Babylon turn the, or close the circuit, so this water pump start to work. So clearly it converts electrical energy because without electricity it doesn't work. But once you connect it, once you turn it on, that's the electrical energy, the motion, and now it can pump the water to the, let's say, water tank or to the top of the roof, and this is converting electrical to mechanical energy, Basha. So the coil will rotate, and then that rotation on that coil will be connected to a shaft. The details will be covered shortly, Basha. Yeah, good man, that would be for that. But what exactly the base of a motor, Baba Galibi? Good man, what exactly, or how is exactly electrical energy will convert to mechanical energy? It's good base achieve, Baba. We have to connect it to a power supply. Maybe let me draw a diagram, or maybe we could do it right here. As you can see here, which is inside a magnet, there is a commutator, there is a power supply here. Could be battery, could be AC, doesn't matter at this point here. But once you, for example, give it a power supply, now current flows through the coil. As current flows through the coil, which is inside a magnetic field, in chapter 5 we've studied that. when a current flows through a wire, a conductor, inside a magnetic field, there will be a force on it. But this force now it is going to rotate the coil. We can call it a torque, and that would be for this part right here. So to answer this question, what causes the rotation in an electric motor, or what is the working principle of electrical motor? It is the magnetic force or the torque that acts on a current conductor inside a magnetic field then causes the conductor to rotate. In motors, a current of course must be supplied, a current must be flowing through the coil. There will be no magnetic field or no magnetic force acting on the conductor here. What are the main parts, or you can say, what are the main parts of an electrical motor, by the way? The electrical motor is very similar in construction to DC generator. The DC generator magnet man here, coil man here. We have commutator, and we also have, let's say, brushes or carbon brushes, and two brushes you could say. We do have exactly the same part in construction at this point right here. Let's talk about the function and the role of each as well. The first thing that we have, you can say, magnetic field or permanent magnet. At the ishancia magnetic field, it provides a magnetic field so that it produces it would provide a magnetic field for the wire that carries current so that there will be a force on it. Magnetic field provides a magnetic field strength. The coil of wire, what exactly does a coil of wire do here, Baba? When current flows through the coil of wire that is inside a magnetic field, there will be a force on it, and that force will make it rotate. So as the current flows through the coil of wire, it starts to rotate. This is the point where we can say electrical energy will be converted to mechanical, to rotation, to motion. And then we have a commutator. What is exactly the main job of a commutator, Baba? We'll say it reverses the direction of the current. If it is AC, obviously, every half a cycle. But the commutator will always keep the coil to rotate in one direction. What exactly do we mean by this, Baba? At this point here, this coil will be rotating. You can see that this part of a coil is connected to this bubbling part of a commutator, or this part of a split ring here. But as the coil is rotating now, this part will be connected to the other side. And you can see that based on this, this side is positive, like ADK is negative, right? So as this side is negative, the other side is positive, and the rotation is like this. But now at this point here, if we did not have a commutator, this coil would be connected to the other, for example, or let's just keep it this way, If this part, or if we did not have a commutator, once this coil or this part of a coil is flipping here, direction force coil would have been flipped as well, because now the coil has flipped, and is rotated. Connect it would move half a turn forward, half a cycle forward, and then half a cycle backwards. Direction reverse direction motion reverse. But this commutator does not allow that to happen. One side of a coil, that is this side here, no matter what, it is always connected to this side, or you can say this side is always negative, it is always positive. The current will always flow from this side here to the other side and then back to the battery here. If that is the case, then of course that ensures that the coil will rotate in one direction only. To keep the rotation of the coil in one direction. To reverse the direction of the current so that the coil will be rotating always in one direction. It would have rotated half a cycle forward, half a cycle backward. But if it keeps rotating in one direction, then that is the point where it can be useful. بس یک شيء كشمانه ليرة أدي إشي carbon brush كان يعني بابلين two brushes تبو بتمانه keeps and maintains contact between the wire and the coil باشا so that the current can keep flowing. بس ليرة flowing like how is it flowing? Not out side of the coil, it is flowing into the coil because now we're given electrical energy into the coil. بس يك شيء كهيلي رزوزو جرينجا قالبي ضلنا as a motor دتواني بلن a motor can perform a mechanical work. باشا استاكو لك it is rotating. How can we benefit from this rotation? You have to connect a shaft, Basha. We call it a shaft, Basha. Now, once you connect the shaft to another thing, for example, could be any other thing, Basha. Now, this shaft will rotate the object. Now, we can benefit from this. In the case of water pump, for example, this shaft can be connected to the pump. Now, it can pump the water, let's say, to the top, and this is how water can be taken to the top of the roof, let's say, or to the water tank. Could be any other thing, by the way, Basha. This is basically how it works. It could be a wheel, for example. When you have a motor, especially in these, for example, electric cars, this coil is connected by a shaft to the wheel. Now it can rotate the tires, and now the car can be driven. Basha. Now, ليرة بزيك خالدي كشمانية. Basha, which zozo gringa. And that is the next one here. A motor can perform a mechanical work when a shaft is connected. You know this one here. As this part right here, as the coil is rotating here, the changing normal component of a magnetic field through through it induces something else, Basha, induces another EMF that is induced, Basha. This EMF will be opposite to the EMF that is applied on the coil, and that is called back EMF, Basha. Kata, what is back EMF, Basha? What is back EMF, Baba? The back EMF, it is the induced EMF, Basha. This is only special, we can say it is specific for motors, not generators, Basha. Kata EMF or back EMF, it is the induced and the opposing EMF, Basha, that is induced inside the motors and coil of a motor, Basha, that tends to reduce the current in the coil of a motor. What exactly is this, Baba? Again, later there is a current that is flowing through this wire this part of a coil. Let's just call that coil here. The current is flowing through a coil, but this coil is rotating, correct? And we've learned that previously there are magnetic field lines, right? Going from north to south, you can see here. Basha. As this coil is rotating inside a magnetic field, are these coils cutting through the magnetic field lines or not? They do, right? You agree, that's a good thing. The coil is cutting through the magnetic field line. Is that as a result of this? There will be an EMF that is induced inside this coil here. That EMF will always be opposite to the EMF that is applied to the coil, and that is called back EMF. Basha. What is back EMF? لا أنزامي سورانوي كويلة كيلنا magnetic field line كان باشا that induces an EMF on the coil. بس أو EMF أي كالسر كويلة كدرس بوا بابلنا positive side كيا, it is always going to be opposite to the voltage and the current that is applied on the coil. باشا كاتا, let's say this is the coil. Let's say the voltage that we provide to the coil, it is 12 volt, let's just say, Basha. Because the coil is rotating inside a magnetic field, voltage induced, Basha. This induced voltage, it is always opposite to the voltage that is applied to the coil. Basha. This opposite voltage here, obviously it is opposite, it is going to what? It is going to reduce the total voltage that is applied on the coil. Basha, this EMF that is induced, it is going to be opposite to the EMF that is applied. This one is applied by the battery. Because the coil is rotating, these two will always be opposite to one another. Basha, get opposite be. Do they, for example, subtract or do we add them? Of course we subtract them. Let's just say it is 8 volt. That's too much, but still it doesn't matter if it is too much or not actually at this point here. If I want to know how much is available on the coil, Basha, how do we know how much is available? If you want to know how much EMF is available, Basha, so we'll say the one that is applied, Basha, EMF applied, minus the EMF that is induced, or you can call this one back EMF. Basha? But later, the one that is applied, if we assume it is 12, the one that is induced, if we assume it is 8, how much will be available on the coil? It is going to be 4 volt only available on the coil. Basha? وطبعا تتوانين بلين أجر EMF استا applied voltage on the coil is reduced when it comes. Let was they we're supposed to give 12 volt to the coil when but because of this back EMF now استا تنها تساعد تسير coil اللي برسه back EMF it is in opposite direction كوتا هندا تشيله دباتني عن بابلنا opposite دكا بس یک شتی دیگه شده بزنی اگر voltage سر کویل کی کم کاتن کاتا current کتیله ده طبعا current کش کم دکا because voltage and current are directly proportional to one another. اگر voltage کم کاتن کاتا current سر کویل کش تیله ده کم دکا و طبعا هتا current و voltage کم بیتن کاتا روتیشن کش كم تردبي بس یک شيء که با بعد لیبی this is what is called قلت مان او باقي مثلا انزامي تدرس دبي الانزامي روتيشني كويله كيله نا magnetic field دشي درس دبيتن هم زاري باقي مثلا like at all points it is always opposite to the applied EMF باشا ودتوانين بلين او opposite to the applied هم زاري او باقي مثلا reduce بابلين تسبدلن reduce voltage او current دكا كوال سر كويله كيا وطبعا efficiency موتور كش كم دكا تسونك like the current and the voltage that is on the motor is going to be less يعني بابلن بشكل energy كم دكاتو يعني بخساري دا but طبعا of course this could be useful too because if there were no back EMF أوقاتي the motor would keep oscillating, let's say rotating faster and faster and forever. You can think of back EMF the same as a perhaps as a matter of fact as air let's say resistance. For example, you're driving a car. And by the way, I did not mention this one. The faster the coil rotate, okay, o EMF ko induce boazat yan bablan o back EMF zat trdebiten kata available voltage come through trdebito. In other words, the faster the rotation, the more the back EMF will be induced. Hata EMF ka back EMF ka zat trdebit taman current ka jdatwani blan o induce debi zat trdebit no kati current available voltage available ster coil ka kam debito. So if you go back to the air resistance, imagine you're driving a car. The moment you start moving forward, the resistance starts to grow more and more and more. The faster you move, the more the air resistance. Because it basically wastes energy. But it doesn't allow you to, for example, speed up forever. That could be good for motors. If not, for example, it could burn them. Because at some point, current it might burn them, but that is not for you to know. Basha, it's totally fine. Back EMF, it is the, we can say that it is the what was it, good man? It is the what is it called? The opposing voltage. Basha, the twanin blend. It is the opposing voltage and the EMF that is induced in the motor's coil, Basha, tends to reduce the current that is on the coil. That's why in back EMF opposite voltage deka kwada cita sar coil ke kubzani, like how do we know or like what would be the available voltage on the motor? The twani know begin equation twani belan the EMF available on the coil deka that say the EMF supplied and bubbling applied onto the coil minus the back EMF that is induced. Once you, for example, do the two, then you could get a result that would be the voltage available on the coil, and that available current, voltage determines how much current will be on the coil as well. Basha, Katari back EMF is the EMF that is induced in a motor's coil that tends to reduce the current in the coil of the motor. The faster the coil rotates, the greater the back EMF becomes. Potential difference available. The EMF applied minus back EMF debita EMF available. وطبعا EMF is using ohms law I times the resistance. The less the available, the less the current that is passing and flowing through the coil. Consequently, the current will be less. As a motor turns faster, the faster the rotation, both the net EMF available on the coil and also the current that is flowing through the coil will reduce. voltage و current بنا لسر coil و بنا coil که دادران کم تر دبیتو. اگر لی بابا دتوانیم بلند back EMF reduces the efficiency because it reduces the current flowing through them and bubbling through it. بسارش دي كمان بساري حفظة. What is meant by the back EMF and how is it induced inside and bubbling in electrical motors? قلت man back EMF بابا it is the opposing voltage. يعني bubbling of voltage كوا induce دبيتو opposing of voltage دكا كوا لسر coil باشا. It is the opposing voltage. How is it generated? It is generated when a coil rotates that carries current that rotates inside a magnetic field. When you got man that induces an EMF within the coil, which reduces and opposes the voltage and the EMF that is on the coil. This induced voltage opposes the applied voltage, reducing the net voltage and the current in the motor. What happens if a commutator is not used in motors or were not used? If commutator ishi commutator يتسبو قد ما الموتور it reverses the direction of a current every half a cycle so that the rotation keeps or the motor keeps rotating in one direction. أجر commutator نبي direction current reverse نبيتوا أو كاتي motion like it doesn't rotate in one direction. قد ما it rotates half a cycle forward, half a cycle backward أو كاتي it ends up with no rotation at all. Kata without a commutator, motors wouldn't be able to reverse direction of the current basha in the rotor's coil, and this reversal is very necessary to maintain the interaction between the stator's magnetic field, which is essential for generating torque and rotation. يبدو عندك بساري وزاري زور سريع كمان ضل a machine that converts electrical energy into mechanical. باشا قلت معنا electric to mechanical أو دبيته موتور أديقر mechanical دبوا electric بوبا أو كاتي دبوا generator أقل دو خالي بيتن dash is a machine that converts the same thing we can say. The operation of an electric motor depends on what? The operation of an electric motor depends on the Doppler effect, photoelectric effect, the magnetic force on a current conductor inside a magnetic field. That would be the correct answer. Induced commutators or whatever this is, nothing much. What is the meaning of the back EMF? What is the meaning of back EMF in a motor? Of course, it would be about back EMF, but which one exactly? It might not be very clear, but hopefully one of the equation about EMF. Basha, Kata, what is the meaning of back EMF? Back, you can think of this one as opposite, Basha, backward, or something that opposes. Basha, back EMF in the motor. A decrease in the permanent magnetic field. Direction or the direction of back EMF, it is opposite to the direction of the applied. This one is good. Let's keep this one in mind. Current inside a coil increased permanent magnetic field. That is incorrect, so we can say B, because back EMF direction it is opposite to the direction of applied. When a coil of an electric motor rotates faster, if it rotates faster, back EMF we said that the faster the coil rotates, the more back EMF. Net. If the question is about the available voltage and current, they both decrease. But the faster the rotation, the more the back EMF will be induced. The faster as it rotates, the motor rotates faster, back EMF, does it decrease? No. Does it increase? Yes. It decreases and then becomes constant? No. And then does not change? That is incorrect. So, of course, the answer is going to be B, Basha. So, the faster the coil rotates, and as it rotates faster, back EMF زياد دكاتن. What if the question says, as the coil rotates slower, right? Will the back EMF, is it going to be, for example, will it change direction? No. It is still going to oppose the voltage, but we said that the faster the rotation, the more the EMF. rotation slow EMF but of course it's going to be less compared to before. In which of the following back EMF is induced? Back EMF it is we can say it is specific for motors at this point, right? So AC generator, DC generator to motor or both A and B, no Basha, it is only for motors. The potential difference that is available to supply the current to the motor while working, it is equal to what? It is equal to the potential difference between the applied and the back EMF. That would be the yes, right? What about this one? The addition, it's not the addition. It is the applied potential difference, no. Only the back EMF, no. Kata Gutman available. Okay. It is equal to the difference between the applied, Basha, minus the back EMF, Basha. Whatever the answer is, that is going to be the available voltage on the coil. I believe that'll be it for this session. Next time, inshallah, we'll start with mutual inductance. Till then, keep practicing, and I'll see you soon, inshallah. Assalamu alaikum wa rahmatullah.